Hi, this is a video where we're going to cover naming and writing formulas for covalent compounds and for acids. So when we name a covalent compound, also known as a molecular compound, some of it's similar to how we name ionic, but some is different. So one thing I want you to take note of is that you have a pink sheet, and on that pink sheet you have these prefixes. So we are going to use those in just a second. But before we do that, let's just look at, so for this compound, this is a molecular or covalent compound because these are both nonmetals. So when you have two nonmetals together, then the first element, the carbon, just gets named carbon. Nothing changes about it. And then the second element, like we did with ionic, this will change the suffix to "ide." So this would be the name of the compound if it were ionic, would be carbon chloride. But there's different combinations sometimes of the way carbon and chlorine can bond, and there's other formulas that also have those elements. So because of that, we need to differentiate and kind of in the name tell how many carbons and how many chlorines there are. So the name of this is going to be carbon, and then we would say tetrachloride. So I'm using prefixes to tell how many elements there are. Notice that I don't use mono when I only have one of the first. I don't use mono. But yet, if I were to name, this, I would call this carbon. I don't use a prefix, but I do use monoxide. I do use the mono on the second. So it's only the first element that if it is only one, then you don't use mono. But otherwise, there's prefixes on both the beginning and the end of the name. Also, just notice the mono and oxide. It would have been double O, which looks kind of weird. So we do drop one of the two vowels. So naming, here's an example. You can try this, and then you can check with me if you want to pause the video. So we know it's going to be phosphorus. We know it's going to be oxide, but what we're going to add is di, and then pent. Notice I dropped the A from penta because there was a vowel on the oxygen. So here's some examples that are on your guided kind of worksheet. If you want to try these, pause it and then check how you did. So the first one is going to be germanium, trigermanium, because there's three of them, dinitride. Second one is going to be oxygen, no mono, monochloride. Third one's going to be dicarbon, tetrachloride. And then this one's going to be nitrogen, trichloride. So going the other direction, writing the chemical formula now for a covalent or molecular compound is pretty easy. You don't have to look up any charges. We just look at the prefix, and then that becomes the subscript. So silicon, tetra, hydride comes from hydrogen. The ending got cut off, and so it is just hydrogen, and there are four of them. So this tetra, and notice there was no mono, but that implies I have one of the silicon. So here's an example. Dinitrogen pentoxide is used as a robust oxidizer for high fuel rockets. So we know that we have two nitrogens, And then we have 5 oxygens. So let's do some more. Again, I would pause the video and try these and then check with me. So this is going to be dihydrogen monoxide, which is water, disulfur decafluoride. This one I want to point out that we do not reduce these. In an ionic compound, we do reduce, but not in covalent molecular compounds. This one's going to be diphosphorus trioxide and nitrogen dioxide. Another thing to note is NO2, nitrogen dioxide, is a compound. There's also a polyatomic ion called nitrite. These are not the same thing because this does not have a charge. Now we're going to switch to acids. So we're going to cover this pretty simply right now, and then later we have a unit on acids and bases. So for now, what you need to know is that an acid will produce hydrogen ions when it's added to water. Another thing, it pretty much works, except for don't use this for water. Acids will start with hydrogen. So example, HCl, H2CO3, H2S, those are all acids. So there's different types of acids. Binary acid, bi means 2. So these are always going to be just hydrogen and then one other element. And it doesn't mean just one, like you could have HBr, but you could also have H3N. But still, even though there's a subscript on the second one, there's still only 2 types of elements. So when you do these, and again, this is this helpful part is on your pink sheet. When you do these, you're going to use this helper. So if I were to name HCl, it's going to be hydro, and then I take the root of that element, chlorine, so chlor, and then ic, acid. So this part corresponds to the nonmetal anion. So I'd like you to try these. There's actually 4. I would try them and then check with me after you pause the video. So here, hydrochloric acid. This is hydrofluoric acid. Hydrosulfuric acid. That one we add an and then this one, hydrophosphoric acid. So we kind of add, I guess that one you just take off the us from phosphorus. And this one, you take the whole, not just the stem of the word, of the element sulfur. So writing chemical formulas for binary acids, you're always going to write the hydrogen first because it is still a cation, and then the anion, the nonmetal, goes second, and then you do want to make sure the charges are balanced. They add up to 0, just like ionic. So HBr, hydrogen is hydrobromic acid. These already add to 0, so it would just be HBr. Hydrophosphoric acid, hydrogen is plus, phosphorus is -3. Bring down the 3, so H3P. So here's a couple more examples. Again, I would try these and pause the video and then check. Hydrosulfuric, So we know it's going to have hydrogen and sulfur. And this one I'm just going to do a different one because we had already done hydrofluoric. So hydroiodic acid would be hydrogen with iodine. Hydronitric acid, bring down the 3. So now we're going to switch over to a different type of acid. These are called oxyacids. So they have an oxyanion in them. If you remember on our pink sheet, oxyanions are just the ions that have oxygen in them. So here's one, pretty much all of these are oxy except for these. So they all have oxygen in them. And if they are with a hydrogen on that, then we are going to call them an oxyacid. So my example here is H2CO3. So when we name this, we don't use hydro. So what we want to do is if we go back to our pink sheet, this naming helper, if we're looking at the polyatomic ion, if it ends in 8, then it becomes ic. If it ends in ite, the polyatomic ion, then the acid name ends in us. So this is carbonate, and 8 changes to ic. So this is carbonic acid. Here's another few examples you could try and then pause and check how you do. This one here, that ion is called oxalate. So this becomes oxalic acid. Let's change this one to a 3 so that we haven't done any yet with the us. So this one, the NO3 part of this compound is called nitrate. So then this becomes nitric acid. This one, the poly, is called phosphite, and ite goes to us. And we do add that OR. So notice no hydro. We know there's a hydrogen because we know it's an acid. So writing the chemical formulas, you have to kind of reverse what you were doing. So if I try to write the formula for this, ic came from 8. So I'm going to look on my pink sheet for phosphate. And that is PO4 -3. And then I know it's hydrogen, it starts with hydrogen. So for this one, I would crisscross, balance the charge so it adds up to 0, it's neutral. So H3PO4. So here's some others that kind of lead you. So ic comes from 8, acetate, and it's with hydrogen. And it's just going to be a 1-to-1 ratio. This one, us, comes from ite. So I look for sulfite with hydrogen, crisscross, H2SO3. So here's another couple examples you could try, and then pause the video and then just see how you did. So hypochlorous comes from hypochlorite. Hypo is not hydro. It's actually a poly. and it is on here somewhere, right here. So ClO is negative with hydrogen. So the formula is going to be HClO. So here's some more. Chloric comes from chlorate. And if I'm right over here, ClO3 with hydrogen, so HClO3. Phosphorus comes from phosphite, which is somewhere. Where is it? It's hiding right here. So PO3 negative 3, so H3PO3. Carbonic comes from carbonate. Formula is H2CO3. And hypochlorous, we just did that one. We'll skip that one. It was HClO. So that is it for the lesson. But what I want to talk to you about is the harder part is kind of putting this all together, mixing up the ionic, covalent, and acids, and knowing how to name and write their formulas. So ionic compounds, the first thing you have to be able to do is just look at a compound formula and know what type it is. Ionic is always going to be a metal and a nonmetal, or there's going to be a polyatomic ion. Covalent is going to be a nonmetal and a nonmetal. And we're going to count the metalloids as nonmetals when we're doing this. They're not nonmetals, but we're going to count them as being a nonmetal when we're trying to determine what kind of compound. And then acids, remember, are going to start with hydrogen. Formula writing for ionic, you do use the crisscross technique. So you need to make sure that the charge adds up to 0. You don't reduce. You do reduce, sorry. Oh, goodness. You do reduce. So for example, if you have lead with sulfite, and you crisscross, you're going to get Pb2SO3 4. And when you reduce, you never touch the subscripts of the poly, but these two are both divisible by 2. So you would end up with PbSO3 2. Nonmetals, the prefixes, covalent compounds with nonmetals, the prefixes become the subscripts. So there's no crisscrossing. You don't need a balanced charge. You just go with the name. And acids are always going to be hydrogen and then some other anion with a negative charge. And you will crisscross these to write the formula. Naming. So when I name ionic, I don't use prefixes. And the rules for naming is in another video, but just may remember you don't use prefixes. So even though this looks kind of like it might be covalent, it's a simple binary compound. This is a metal, this is a nonmetal. So this is not disodium monoxide, it is just sodium oxide. Naming covalent compounds or molecular compounds, you do use prefixes. And then the naming for the acids, remember hydroblankic acid if it's binary, otherwise 8 for the polyatomic ion will change to us acid, ic acid. Oh my gosh, I'm making mistakes, sorry. Ic, and then ite ending polyatomic ions become us. And that's all I have.